Hey everyone, and welcome back to AI Paper Podcast. We're diving into a paper that's causing quite a stir. It's called MATH-Perturb, benchmarking LLM's math reasoning abilities against hard perturbations.
Yeah.
And well, it really gets at this question. Can LLMs actually reason mathematically, or are they just really good at memorizing?
It's a big question, right? And this paper, it takes a really interesting approach to try to figure that out.
Yeah, the researchers, Kai-Swen Hong and the others, they created two new datasets, MATH-P-Simple and MATH-P-Hard. And they derived these from the already pretty tough math dataset, zeroing in on the hardest problems.
And that's where things get interesting. So MATH-P-Simple, it uses these simple perturbations. Basically, think of it as, tweaking the numbers in a problem, but you're not changing the underlying math concept.
So kind of like seeing if they can handle variations on a theme.
Exactly, yeah. Can they generalize what they've learned? But then MATH-P-Hard, that's where the real challenge comes in. These hard perturbations, they actually fundamentally change the nature of the problem. You need a whole new level of reasoning to solve it.
It's like changing the rules of the game completely.
Exactly, yeah.
And to make sure the LLMs weren't just like spitting out memorized answers, they ensured that the solutions to the perturbed problems were different from the originals.
Yeah, really clever, right? They wanted to push these models and see if they could truly adapt.
So let's talk results. They put 18 different LLMs to the test, some big names like Gemini and GPT, as well as some that are specifically designed for math. What did they find?
Well, even the best performing models saw a pretty big drop in accuracy when they were hit with those hard perturbations, sometimes as much as 25%.
Wow. So even the models that aced the original math dataset, they struggled when the problems got remixed.
That's a great way to put it. It really suggests that while these LLMs are great at applying what they've learned to familiar problems, when things get really novel, they struggle. They don't have that adaptability that we see in, human mathematicians.
This is huge. For anyone working with LLMs or in AI, I thought it was interesting how they explored how LLMs memorize information. It's not just rote learning anymore, is it?
No, not at all. They found this thing called the Memorization of Technique. Basically, LLMs seem to be memorizing these problem-solving techniques, and then they just apply them blindly, even when the problem's context has completely changed.
So it's like they've learned a specific dance routine, and they just keep doing it no matter what music is playing. That seems like a recipe for disaster, right?
Yeah, absolutely. The paper gives this great example. A model correctly simplifies a function in the original and simply perturbed problems. But then, with the hard perturbation, that simplification is totally invalid. They missed that.
That's a big blind spot.
Yeah, it is.
It highlights the need for models that can really understand the underlying principles and, adjust their strategies when things change.
I agree. It's not enough to just mimic human problem solving. We need LLMs that can actually reason and adapt.
So speaking of deeper understanding, the paper also looks at in-context learning, which has been getting a lot of buzz. The researchers wanted to see if giving the LLMs the original problem and solution as a hint would help them with those harder variations. What did they find?
So sometimes giving them that hint actually improved their performance on the harder versions.
Okay, so a little extra context can be helpful. But that wasn't always the case, right?
No, it wasn't. Sometimes giving them the original problem and solution actually made things worse. It was like they were fixated on that original solution, and they missed the subtle but really important differences in the new problem.
Interesting. So in those cases, the hint became a distraction.
It seems that way, yeah. It's like it stopped them from really thinking critically and adapting. It kind of shows a vulnerability in how LLMs process information.
Right. It's not just about blindly following an example. It's about fostering genuine reasoning and adaptability. So how do we do that? How do we encourage that kind of problem solving in LLMs?
Well, that's the million-dollar question, isn't it? This paper doesn't have all the answers, but it definitely lays out a path for future research.
It's a call to action for sure. We need to develop training methods that encourage genuine reasoning and adaptability in these models.
Absolutely. We need to move beyond just surface-level performance. It really is a call to action. And this paper, it raises a lot of interesting questions about the future of LLMs. How do we unlock their full potential?
Yeah, I think what's so important here is this idea of evaluating LLMs in a much tougher way. Like these hard perturbations, they really show us where these models are still lacking, right?
Absolutely, yeah. I mean, traditional benchmarks, they often focus on problems that are very similar to what the LLMs were trained on. But as we saw with MATH-P-Hard, that's not enough.
It's like you said before, giving someone a driving test on a straight road and then expecting them to handle like rush hour traffic in a big city.
Perfect analogy. These hard perturbations, they force the LLMs to think outside the box. Can they really adapt? Can they reason through these new challenges?
And that's what we need, right? If we're going to have LLMs that can be trusted to do real-world stuff. Speaking of real-world applications, the paper talks about this thing called inference time scaling, which seems pretty useful for improving LLM performance. Can you explain what that is?
Sure, yeah. Inference time scaling basically uses multiple inferences from the LLM to try to get a more accurate answer, like, getting a second opinion before you make a big decision.
So instead of just taking the LLM's first answer, you generate a bunch of different solutions.
Right.
And then you, combine them somehow to get the best one.
Exactly, yeah. And one way to do that is self-consistency, sometimes called majority voting. You basically take a vote among all the solutions and see which one gets the most votes.
That's clever. So if the LLM is actually reasoning about the problem, you'd expect those different attempts to kind of converge on the right answer.
Right. And the interesting thing is, the researchers found that inference time scaling, especially self-consistency, it actually did improve accuracy, even on Math-P hard.
That's promising. So even with these limitations, there are ways to make LLMs more reliable and accurate.
Absolutely. And it shows that we need to be creative, There are lots of different ways to improve LLM performance. It's not just about building bigger models.
Right. This research definitely opens up a lot of avenues for future exploration. One thing I keep thinking about is this memorization of technique idea. What are the risks of LLMs just blindly applying those techniques without really understanding what's going on?
Yeah, that's a big question. I mean, one risk is that they could fail spectacularly when they encounter something totally new outside of their memorized techniques. It's like having a toolbox full of hammers when you need a screwdriver.
Right. They might try to force a solution using the wrong tool. And that could be really bad, especially in situations where safety is important, like healthcare or self-driving cars.
Exactly. And another risk is that it could stifle creativity, If LLMs are always relying on these memorized tricks, they might miss out on discovering new and better solutions.
It's like we need them to think outside the box, not just regurgitate what they've been trained on.
Exactly, yeah. If we want LLMs to be true partners in exploration and discovery, they need to be able to understand and reason.
So how do we get there? How do we move beyond this memorization of technique and teach LLMs to truly understand? The paper seems to suggest that training methods are really important here.
They are, yeah. The researchers argue that we need to go beyond just feeding LLMs massive data sets of problems and solutions. We need to find ways to encourage them to develop a deeper understanding.
So what might that look like? What kind of training methods could we use?
Well, one idea is to use more diverse and challenging data during training. Push those models out of their comfort zone and force them to develop more robust strategies.
So instead of just giving them a diet of similar problems, we need to give them a more varied menu.
Exactly, yeah. And another idea is to use feedback mechanisms during training. Let the models learn from their mistakes and refine their understanding over time. It's like having a tutor who can guide them along the way.
That's a great way to put it. It seems like there's so much exciting work to be done in this area. We need to explore these new training paradigms and see what's possible.
Definitely, yeah. This paper is a call to action for the entire AI community. We need to rethink how we train and evaluate LLMs. It's about moving beyond benchmarks that just measure performance and focusing on building models that can actually understand and reason.
This research has really got me thinking. One question I have is, how do we measure that deeper understanding and reasoning? It seems like our traditional metrics might not be good enough.
That's a great point. I mean, traditional metrics often focus on things like accuracy, but they don't always capture the nuances of reasoning. We need new ways to evaluate these more subtle aspects of intelligence.
So what might those new evaluation frameworks look like?
Well, one idea is to create benchmarks that go beyond simple problem solving and require LLMs to demonstrate their understanding of underlying concepts. Like, maybe they have to explain their reasoning, justify their answers, or come up with new solutions to unfamiliar problems.
It's not just about getting the right answer. It's about showing how you got there.
Exactly, yeah. And another important thing to consider is the broader societal impact of LLMs. We need to make sure they're not just effective, but also ethical and aligned with human values.
That's a crucial point. As LLMs become more integrated into our lives, we have to make sure they're not just smart, but also responsible.
Absolutely. This paper reminds us that developing truly intelligent and trustworthy LLMs requires a big picture approach. It's not just about technical advancements, it's also about ethics, and societal impact.
This paper has sparked a lot of interesting discussion. I'm curious to hear your thoughts on one specific thing they mentioned. Mode collapse. What is that and why is it important here?
Sure, yeah. So mode collapse is this phenomenon that can happen in generative models like LLMs. Basically, the model's outputs become less diverse over time. They kind of get stuck in a rut and keep generating the same kinds of responses.
So even when you give them new information or a slightly different problem, they just keep spitting out the same answer.
Exactly, yeah. And that's bad because it shows a lack of understanding and generalization. The LLM might be able to generate impressive outputs for familiar prompts, but it can't really adapt to new situations or be truly creative.
It's like they've memorized a script and can only recite those lines, even when the situation calls for improvisation.
Exactly, yeah. And the researchers actually found evidence of mode collapse in some of the LLMs they tested, especially when they were faced with those hard perturbations.
So even though these models did well on traditional benchmarks, those hard perturbations exposed a weakness in their ability to generalize and learn from new information.
That's right. And this highlights the need for new training and evaluation methods that can discourage mode collapse and help LLMs become more flexible and adaptable.
It's clear that we need a more sophisticated approach to developing and evaluating LLMs, and this paper does a fantastic job of highlighting those limitations and pointing us towards some potential solutions.
I totally agree. This is a really important contribution to the field, and I think it will have a big impact on future research.
This deep dive has been incredibly insightful. I'm especially struck by the emphasis on training LLMs to not only generate correct answers, but to really understand the underlying principles and reason logically.
Absolutely, yeah. That's the key takeaway here. We need to move beyond evaluating LLMs solely on their ability to mimic human performance. We need to focus on building models that can actually understand and reason their way through complex problems.
And that's an exciting prospect, right? Imagine LLMs that can help us with scientific discoveries, solve engineering challenges, and maybe even help us understand the universe in new ways.
I know, it's amazing to think about. The future of LLMs is bright, but we have to be smart about it. We need rigorous evaluation, thoughtful design, and a focus on developing models that are not just intelligent, but also reliable, adaptable, and ethical.
I think that's a perfect note to end on. Thanks for joining me on this deep dive into the world of LLM reasoning.
Yeah, it's been a really interesting discussion. You know, it really makes you realize we're still just figuring out how these LLMs learn and how they reason.
We're just getting started, right? And this paper shows how important it is to have better ways of evaluating them, really put them to the test.
Absolutely. And the researchers here, they really went all out with these new data sets, Math-P simple and Math-P hard. They didn't just throw any math problems together. They brought in experts to create problems that would really challenge those higher level reasoning skills.
So they brought in the A-team to make sure these data sets were tough enough.
Exactly. They had 12 PhD students, all with strong math backgrounds, helping to design and choose the problems.
Wow, that's serious. It makes these findings even more impressive, right?
Yeah, definitely. They were so careful about creating these data sets. It sets a new standard for this kind of research.
It raises the bar for how we evaluate LLMs, especially when it comes to reasoning. And it shows how important it is to be transparent and rigorous when we're designing these benchmarks.
For sure. It's not enough to just show that an LLM can do well on some tasks. We need to know how it's getting those answers, what kind of reasoning it's using, and where it might fall short.
This research really reminds us that even though LLMs have come a long way, we still have a long way to go. We need to keep pushing the limits, trying new training methods, and coming up with better ways to evaluate them.
Absolutely. The goal is to create LLMs that are not only intelligent, but also reliable and adaptable, LLMs we can trust and that line with human values. And this paper gives us some great ideas of how to get there.
It's been an amazing exploration of the challenges and opportunities in building LLMs that can truly reason. What a fascinating deep dive.
It really has. This paper is a major contribution, and I think it will have a big influence on future research in this area.
Well, that's all the time we have for today. Thanks for joining us for another deep dive into the world of AI research. We'll see you next time.